part of the mantle. Okay, so it's that like in-between layer of the earth. This constitutes the hard, rigid outer layer. Okay? Underneath the lithosphere, we have the asthenosphere. And you don't have to write this down because you don't have a piece, but this is good for you to know because it is in your book. Okay, so the asthenosphere is the layer that lies below the lithosphere. Do you remember hearing about this in the plate tectonics? Yeah? Okay. It's a solid layer of rock that has pressure and heat, and it flows like a liquid. Okay, so it flows kind of like the magma. Okay? Okay, the mantle.
Yes.
Okay. So go ahead and copy the lithosphere and the asthenosphere. Yeah. Well, I would copy it on the back because you're going to cut it out. But you can copy it. Can I borrow yours? Okay, so you can copy it. So since this is between the crust and the mantle, you can just copy it underneath if you ran out of room on lines underneath the crust. Okay, and then when we go back to draw our picture, you can actually label it. So you can put the crust, and then the lithosphere, and then the asthenosphere. Okay, so the mantle. So that's the next page in the book, and that's also the next layer. So it's composed of hot magma. It has semi-solid rocks and minerals. So if you think of the mantle, you can think of liquid. So liquid magma, right, and then rocks that comprise the mantle. And then if you remember from our plate tectonics activity, this is where tectonic activity occurs, right? So our crust subducts and seafloor spreading, it subducts into the mantle and is recycled. So this is the activity where volcanoes and earthquakes occur. So this is a very important part in the earth. This is where all of that activity occurs. And it's the thickest part. So when you are going to draw this a little bit later on, make this part the thickest. So you can see over here, Mr. Sykes drew a pretty good diagram, that this whole area is the mantle. Okay, so it's the thickest, and keep in mind when we're going down into the layers, they get more dense. Okay, so the mantle is more dense than the crust is. The next layer is the outer core. So a convection current occur here, making Earth's magnetic field. So this is a pretty important layer also. It's composed of iron and nickel. And it's liquid. Okay, so you have two cores. You have the inner core, and then you have the outer core, and then you have the inner core, which we'll get to in a second. The outer core is a liquid. That's the liquid core. Okay, it's very hot, right? So in order to melt rocks, the temperature has to be pretty hot to do that. So this core is very hot. Composed of iron and nickel. Those are the two main elements found in the outer core of Earth. Okay, so just a quick recap, we have the crust. And then we have the lithosphere and the asthenosphere in between. We have the mantle, the thickest part. Then we have the outer core. And we'll talk about the inner core in just a second. Core. So this is the last layer of the Earth. It's a very dense, solid, ball-like shape. It's very hot. It's tight like a ball, so lots of pressure built up in it, and it's composed of mainly iron. you have the inner core. Then you have the outer core. What's next? The mantle. Okay, and then what's next? They're kind of sandwiched in between the mantle and the crust. And then the lithosphere. Good, yeah. And then the crust is the very top. Okay, cut these circles out. And then you're going to draw the crust and the different parts of the earth, okay? So what I would do, what I did first, is I drew the layers. So for the first one, you have your fact in the middle, and then you're going to draw the crust on the outside. Okay, so the crust is very thin, right, compared to the rest of the layers of the earth. So you're going to draw your crust very thin, okay? And then the next layer is the mantle. And this is the thickest layer, right? So I could have done it a little bit thicker. So your mantle should take up most of your circle, the semicircle here, okay? And then the outer core. And then the inner core. Okay, so that's the end product. That's what yours should look like. And each layer, you're going to have to draw the crust again, and then the mantle, and then the outer core. What I would do is I would draw in pencil each layer first. So I would just draw a thin circle around for the crust, and then do the same on the next page, and then draw the mantle. So I would draw in pencil first, so you can see your thickness. So you draw the crust real thin, and then the mantle. And then it would probably be a good idea for you to draw the lithosphere and then the asthenosphere in there too. Okay. So let's review. What goes first? Okay, what goes first? So we're gonna we're not starting from the inside, we're gonna start from the outside, right? So the outside. The crust. Okay, good. What we live on, right? And then okay, go ahead. No? Not the mantle? You don't agree?
Yeah.
Oh, you do agree. Okay. So what is between the crust and the mantle? Okay, good. So if you're going to draw that in, make sure you draw that in. Okay, so you draw it in right there. Kind of like this. Okay, so we have the lithosphere right here, and then the asthenosphere. Okay, then what goes next after? Okay, good. And then next. And then the inner core. Okay, so what are you going to do first? What I would do first. Okay, yeah, you're going to draw the layers first. And then I would color them, and then afterwards, I would cut the circle out. So, can I borrow yours real quick? So you're going to cut on the dotted line. Okay, so you should cut the whole thing out. Once you're finished with everything, with the coloring and the cutting, then you're going to glue the part that says glue to the next page, okay? So, like my crust, the back side of my crust page is glued to the front side of the mantle page. Okay, so your book should look like this when you're finished. Okay, so I think you have the rest of the hour. Oh, and we got the video.
Hey, I'm just making a planet. Well, this is how planets like Earth get their structure anyway, because of different layers of density. Even today, with all of our modern technology, we've only been able to drill about a third of the way through Earth's crust. So, how do we really know if it's solid, liquid, hollow? Luckily, Earth has this tendency to violently shake and occasionally burp up some of its insides. And that's taught us a lot about our planet's guts without having to go down there. We're used to seeing density at work. That's the same reason that the atmosphere, the least dense part of our planet, is on the outside. And the crust, the second least dense part of the Earth, is beneath our feet. Because I'm less dense than the dirt, I don't sink into the ground. And even though there's about 1 ton of atmosphere above my head, it's not dense enough to send me floating. The main layers of the Earth are organized in the same way. Depending on whether they're divided up by how they squish around or what they're made of, geologists give different names to the different layers of the Earth. So that's how it is now. But to really understand why the Earth is organized the way it is, we need to go back to before our planet even existed. in the very young universe, hydrogen and helium were pretty much the only elements around. They condensed into stars, began the process of nuclear fusion, and eventually died, spitting heavier elements from carbon and oxygen to things like nickel and gold back out into the universe. One of those heavy elements, iron, is the most stable element produced outside of a supernova, and the early universe produced a lot of iron. That'll be important in a second. Fresh hydrogen and helium went on to form new stars like our sun, and the heavier elements collided to form the dust and debris that would become our solar system's planets and moons and asteroids and everything else. High temperatures in the early inner solar system meant that light volatile elements could only condense further out, which is why the 4 inner planets of our solar system are dense and rocky, while outer gas giants like Saturn could hypothetically float in a really big swimming pool. After proto-Earth grew larger, radioactivity, gravity, and violent boom booms melted that messy mixture of rocks and minerals, and this is where things started to get organized. Just like that tower of density, the heaviest materials like iron and nickel worked their way to the core. The lighter materials like aluminum and silicon stayed near the surface. The inner core experiences pressures more than 3 million times what we do on Earth's surface, which means that despite being as hot as the surface of the sun, the iron in our planet's inner sphere is likely solid and not liquid. The outer core is most likely liquid because it's hot, but not under as much pressure as the inner core. We know that's the case because of earthquakes appear on the surface. As certain kinds of seismic waves travel through the Earth, the liquid outer core either refracts them or blocks them altogether. And that creates seismic shadows on the opposite side of the planet. If you want to use pressure to melt metal at home, just stack up 16 million pennies. The one on the bottom should liquefy in no time. Mercury is so close to the sun that its atmosphere has long since blown away. But luckily for you and me, our liquid metal outer core lets us have an atmosphere. Deep metallic convection currents create a magnetic field that shields Earth from the solar wind. Otherwise, we'd be pounded with deadly radiation. Our atmosphere would be blown away, and Earth really wouldn't be a very lifey place. Over time, Earth continues to cool, so more and more of its liquid outer core is turning solid, and we're shrinking little by little. Every earthquake that we feel is Earth taking one step closer to cooling off and becoming a real third rock from the sun. So there you have it. Like Carl Sagan said, we are star stuff who has taken its density into its own hands. It's density, right?
On your density.
Stay curious. People have been looking at clouds since people have been people. Those billowing shit.
Hopefully that kind of answered some of your questions about what I talked about in the PowerPoint. Does anyone else have any questions about what you're doing or the book? Nope. Okay, did everyone copy the pages down? So they got the crust, they have the mantle, the outer core, and the inner core. I can go back on the side. If you don't have it, raise your hand. Okay, what's your email?
I get to have all of
The mantle. Who doesn't have a mantle? Raise your hand. Okay, you two. What do you not? What do you guys not have?
I don't have this,
Oh, okay. I'll go back to that side. Okay, so the mantle and then the Asinus regimen and all this. Okay, so I'll go back through those slides. Those of you who want to start working on your drawing and coloring, go ahead and do that now, and then I'll save you this side for you.